All right, so we're talking about proving polynomial identities. Now, this isn't proving like you guys did for geometry, okay? So we're not, that's real proofs. We're proving it, but it's not like a proof in geometry. I'll just leave it like that. We got some vocab. There's identity and polynomial identity, right? We're going to define that right away. And an identity is an equation that's satisfied by any numbers that replace the variables. So then, like we've kind of dealt with this before. So if you remember system of equations, right, we had three options. You could find the intersection, which is one solution. They could be parallel, there's no solution, or they could be the same line with infinite solution. Okay? So when you were working out one, like by elimination or whatever, variables may disappear. So if you remember that situation where all of a sudden there was no more variables, you were either left with a true statement or a false statement. Okay, so if it was a true statement, you said all solutions. That's what they're talking about here as an identity. Is that okay? Thus, a polynomial identity is a polynomial equation that is true for any values that are substituted for the variables. Unlike solving an equation, do not begin by assuming that an identity is true. And so then they go on and say you cannot perform the same operation on both sides. So when you're asked to solve an equation, you know that the left-hand side is equal to the right-hand side. And that's what allows us to add things to the other side, divide through by the same number. But that's not what you're doing here. You are going to work on the left side or work on the right side. Okay, so you cannot combine the two things here because you're trying to show that both sides are equal. Do you understand the difference there? Okay, so basically what you want to do, what the suggestion always is that you work on the harder looking side first. And you can go and work on the right-hand side, and then you can jump to the left-hand side and work on that, but you can't go back and forth between the two sides. Or you can't use them at the same time. You can go back and forth between the two sides. Is that okay? That's what they're saying here. Factor and multiply expressions as necessary. So again, what we're thinking on this example is we're wondering, do these two things equal each other? And that's why there's a little question mark right here. Oops. That's why there's a little question mark right here. Because we're not sure. We're wondering. Okay? So the more complicated looking side, I would say, is the right-hand side. Okay? So we're trying, yeah, right. So and now, you do not have to work on the right-hand side. I'm going to say something about that here after we go through this. But clearly, the more complicated side looks like the right side. So then, what can we do with the right side? Well, we could multiply these things together. We could distribute all of that and see what we end up with. So again, we're ignoring the left-hand side completely. We're taking the right-hand side, and now we're distributing an x. Then we're going to turn around and distribute a negative y. Okay, so then x times x squared, right? So that's what they did here. They just distributed everything I said that they distributed. And now we're going to multiply these things together. So what's x times x squared? X to the third. What's x times xy?
X squared
and y. Okay, and then x times y squared? Xy squared. Negative y times x squared?
Y squared. Negative y x squared.
Okay, so negative y x squared. So usually you say it in alphabetical order, but I'm going to come back and say something about this here in a second. Okay. And then we have negative y times xy. Xy squared. And then finally, negative y times y squared is negative y cubed. Okay, so standard is to write it in alphabetical order. So you'd always write the x before the y. But you're allowed to multiply in any order. So the reason I'm okay with writing it like this is because we do need to understand that just because that is y and then x squared, but this one is x squared then y, they are still like terms. Okay? So make sure you understand that. And then you don't have to worry about writing it in order. Just understand that they are like terms. And that is why on this step, you see them next to each other. X squared y minus x squared y. Okay, and so then we're combining these like terms Notice that both of them cancel out, they're gone. And so then we're down to x cubed minus y cubed. And sure enough, that is the same as the left-hand side. And so we have just proven with air quotes that these two sides are the same. That's essentially all we're doing. Now you could have said, and this would totally be legitimate, you could have said, I'm just going to factor the left-hand side. And then when you factor the left-hand side, we just showed that they're both the same. So when you factor the left-hand side, you should factor it into the right-hand side. Okay? Now I would be careful on that because, if you do it that way, you got to ignore what's on the right-hand side. Because again, not everything that you're going to be given is going to be true. You're trying to show that this is true. Maybe it's not true. So don't just assume that it factors into that right-hand side. So safer to just mess with the right-hand side and distribute and things like that.
So what you're saying is the difficult side is not the most difficult side?
Kind of. The more, because the more complicated it looks, the more options you have to play around with. And the pre-calc people are just about to start this with trig functions. Okay, so it's the same idea except you're doing trig, and there's more complicated things going on with trig. But yeah, that is kind of what I'm saying. Yeah. We got Paul, not Paul, but Frank Ryan. Look, he used to play quarterback for the Browns. He's got a PhD in, I'm going to run out of battery. He's got a PhD in mathematics. Good guy. Good looking guy too, man. What's that? He's up there. This is pre-CTE issues. Right, he played when they didn't have helmets and stuff. Therefore, he can live a long time. Now that they have helmets, they all die like in their 40s and 50s. Right? I'm sure it's fine. But it makes sense if you think about it, right? Like, if you don't have anything protecting your head, chances of you leading with your head are pretty small, right? The only reason you guys can lead with your head is because you're all protected in there. And then you're not really protected, you get brain damage. But who needs your brain? Yeah. Like, who cares if you only live to 40? For you guys, that might as well be to 5,000. Right? 40 is more than twice your age. But I'm going to tell you, you don't want to be out than 40. You want to be around for a little bit longer than that.
That's why they started Pee Wee sports now. They don't even do like contact sports anymore.
Yeah, because they're worried about people's heads. Yeah.
When I was little, I started football when I was 4 contact.
Yeah, right.
But they made it illegal now.
Yeah, because they're worried, especially when you're young.
Yeah, that's bad.
Yeah, because your brain is still growing, and I think your brain grows until you're 25. But yeah, they don't want your all's brains bouncing around.
Yeah.
And again, they could finish this off. CTE could be a thing of the past. All they got to do is take their helmets off. But that ain't gonna happen. Anyway, this guy studied prime numbers, so that's pretty big time. Look at that. He led them to the NFL championship game in 1964. They won. But he's also a math guy.
You still living?
Well, as the print of this book.
When was that?
I don't know. You guys got it. When's the print? When did it get printed? $2020. So yeah, 2020. So. Right. I don't know if he's still around. Think about math still. Pedro claims that you can always create 3 lengths that form a right triangle by using the following method. Take 2 positive integers where x is bigger than y. 2 legs of the right triangle are defined as, here's one of the legs of the right triangle, x squared minus y squared. And the other one is 2xy. And then the hypotenuse would be this. So he's making some statement that we're going to try to prove. And we're wondering, is Pedro correct? So explain your reasoning in the context of polynomial identities. Okay, so if you have a right triangle and you have a bunch of side lengths, then you should be thinking about a certain theorem. Who's? Pythagorean theorem. And what is Pythagorean theorem? What is it? Yeah, what about?
This is like what it is, right?
Well, it involves the side lengths of a right triangle.
Isn't it, a squared plus b squared equals c squared?
And c squared is
C squared is the hypotenuse.
c squared the c value has to be the hypotenuse. The legs are interchangeable. Okay, so anytime you guys have a right triangle and you're talking about side lengths, the first thing you should think about is this formula right here. Okay, and so if Pedro is correct with his statement about these integers, x being bigger than y and then these relationships, then this has to satisfy the Pythagorean theorem. So if you notice what they did here is they took the hypotenuse and squared it. There's their c squared. And then it doesn't really matter which one you label a and b, but there they are. And so now we have this question mark because we're wondering if he's right. So again, we're not combining sides. We're just going to mess with one side. And on this problem, we're going to turn around and mess with the other side as well. Okay, and so then how do you square something? What's going on here? Like, let's just look at the right-hand side. How do you square something? Times it by itself, right? So then you would do this. Right, and then we FOIL. So then it would be x to the fourth plus x squared y squared plus x squared y squared plus y to the fourth. Right, and they combine like terms, and there's the right-hand side. So again, we're going to leave that alone now. And we want to see if the other side gives us the same thing. If the other side gives us the same thing, we're like, yeah, you're right. If it doesn't, then we're saying, no, that's good try. Right? So again, did we all get that? Did we all see what's going on? Right? So again, now we're squaring two different things. You still multiply it by itself. So then we have x squared minus y squared times x squared minus y squared. Right? We FOIL x to the fourth minus x squared y squared minus x squared y squared plus y to the fourth. Combine like terms. We get that. So that was one of the side legs. That was one of the legs. The other leg he's saying is 2xy. So then we square that. Make sure you square the 2 also, and then you get 4x squared y squared. Does that make sense? All right, then you look for some like terms. Right? We got the negative 2x squared y squared, the positive 4x squared y squared. Add them together. Sure enough, he was right, because now both sides say the same thing. And because this identity is true, this proves that Pedro is correct. His process for creating the sides of a right triangle will always work. Is that okay? So that's basically all you're doing. You got one, the check, like walks it through with you. You know, you can just fill in what they were doing. But again, all you're doing is simplifying one or both of the sides and seeing if they give you the same thing on both sides. Do not move terms over. It's not an equation. Okay? Sometimes it's going to be true. Sometimes it's going to be false. So any questions on what to do? You should be able to get this done pretty easily before you leave.